Okay, the next parameter here for your physical examination will be the specific gravity. So specific gravity is actually measured in terms of the density. So this one would be measurement here of our kidney's ability to reabsorb essential substances. So the amount of the substance dissolved in your urine, as with the specific gravity reading here, is highly dependent on the number and the size of the particles dissolved. So I mean to say, the bigger the size, the more the number of the particles suspended on that, so the higher the specific gravity reading. So again, we measure specific gravity most likely in terms of the density. So density here is that is the density of your solution that's being measured, like your urine, is being compared with the density of your distilled water at the same temperature as your standard or calibrated na medium. Okay, so we have here different method for your specific gravity reading. So you could have your direct with your urinometer or your harmonic oscillation densitometer. Indirect, you could have your refractometer. You could also have your reagent strip method for that. Okay, the first method here for your specific gravity reading, we have here your urinometer. Urinometer is just a graduated cylinder with your urinometer float. This is a calibrated, graduated na urinometer float wherein may mga graduation dito sa kanyang stem. Okay, so the problem with the urinometer, you require here a larger volume of the urine because you need to fill this one. So the procedure for this one is just fill this one up to the 3/4 volume and then release here your urinometer float. Iganon mo lang siya paikutin. And then wait until here the urinometer float. We're going to stop and try to measure here kung saan dito tatama ang fluid. So kung dito siya, then you try to read kung ano ang graduation dito or reading dito natin. Okay, your urinometer measures the specific gravity in terms of the density. Okay, so the density here measured by the amount of the volume or the volume of your urine that has been displaced by your urinometer. Kasi pag binaba mo ito, di ba, ang urine natin tataas. Okay, so kung gaano kadami ang solute na nakadissolve dito, the more na urine ang di-displace niya. That's why you try to measure the density in terms of the volume of the urine being displaced by your urinometer flow. So we calibrate your urinometer here with the distilled water. Once you calibrate this one, so the reading here should eventually be at exactly 1.000. There are 3 decimal here after your 1. That would represent your specific gravity. Okay, so this one is also being calibrated at the temperature of 20 degrees Celsius. Okay, then we have here the necessary corrections when you're using urinometer here for the specific gravity reading. So, ang rule natin, we have here in every 3 degrees Celsius temperature increase as to the calibrated temperature of the manufacturer, you need to add 0.001 with the specific gravity reading using your urinometer. On the other hand, in every 3 degrees Celsius lower ang ating specimen temperature as with the calibrated na temperature of the manufacturer, you need to minus 0.003 with the specific gravity reading of your urinometer. Example here, we have for example, your instrument, your urinometer is being calibrated at temperature of 20 degrees Celsius. Pero ang specimen mo, ang temperature ay nasa 23 degrees Celsius. This is 3 degrees Celsius higher compared to your calibrated na temperature. That's why you need to higher siya, you need to add 0.001 with your specific gravity reading. So for example, ito ang reading mo nung may measure mong urine using your using your urinometer, ang reading mo is 1.005. However, here, since ang temperature ng urine specimen mo is 3 degrees Celsius higher than the calibrated temperature of the manufacturer, then you need to correct for your specific gravity reading. itong specific gravity reading with your urinometer, then you need to add 0.001 because again, your specimen would have temperature of more than 3 degrees Celsius higher than calibrated temperature of the manufacturer. Kaya ang pinaka dapat ang specific gravity reading mo is 1.006 as your corrected na specific gravity. On the other hand naman, pag mababa sa 3 degrees Celsius uh, lower compared with the calibrated temperature ng manufacturer, then you need to minus 0.001 with your specific gravity reading of your urinometer. What are the other corrections? Again, if your urine sample here would have high level of protein or high level of glucose, paano mo malaman na high level ng protein sa high level ng glucose? So, i-measure mo siya determine mo siya using your chemical test for the glucose and chemical test for the proteins. But it should be quantitative para may grams per DL na value siya. So, ang rule natin for the glucose, in every 1 gram per DL na glucose, ima-minus mo siya. So, nasa PowerPoint nyo, i-add nyo, but you need to minus that one. I-minusan mo ang specific gravity reading mo ng 0.004. On the other hand, for every gram per DL na protein naman na present sa urine sample mo, you need to minus also your specific gravity reading here by 0.003. Okay, when you're doing your urinometer, so again, you need to calibrate that one with the distilled water. And it should have a specific gravity reading of 1.000, 1.00, tatlo. Before you could proceed with your experimentation. So, dapat makalibrate mo muna siya before you proceed with that. Okay, the next one, we have your refractometer. So, refractometer, parang siyang ganon. Parang instrument ganito. So, okay, this one try to measure the specific gravity here in terms of the refractive index. So, we define the refractive index here as velocity of the light in the air versus your velocity of the light in a solution. So, this one uses only a small volume of your urine. 1 drop lang kailangan natin dito. So, unlike in your urinometer, sobrang dami ng urine ang kailangan natin for you to measure the specific gravity. So, that's one advantage of this one. Okay, so again, try to measure specific gravity here. So all you need to do is first calibrate your instrument. For the calibration, pwede kang gumamit ng distilled water. And dapat ang specific gravity reading mo should be 1.00. Another calibrating medium na pwede natin gamitin would be the 5% sodium chloride. And it should have a reading of 1.022 plus or minus 0.001. Again, you could also have your 9% sucrose, and you should have a reading of 1.034 plus or minus 0.001. So, kung ano ginamit mo dito, pag ang specific gravity reading niya ay hindi na-fall dito sa expected na specific gravity reading, then you need to adjust. Meron itong adjustment screw dito. So, parang ipaikutin mo lang para calibrate siya at that desired na specific gravity reading. Okay, so paano niya mini-measure ang specific gravity in terms of the refractive index? Pagda-drop ka dito ng specimen mo, then i-cover mo siya. Then after that one, dito ka titingin. Okay, try to position this one against a good light source. And then ito makikita mo sa loob nito, dito sa loob. May calibration mark dito. And try to read here the specific gravity reading here at aligned with try to intercepts dark area tapos light area. So dark area here, kung saan sila nag-intercept ang light saka dark area, that become your specific gravity reading. May mga reading naman dito sa loob. Okay, so this is being refractive index here is being presented in the angle here that's being produced as your solution or the light here would eventually try to pass through your solution. So mean to say, pag zero kasi siya, ganito, di ba, straight ang line natin. Kasi walang laman or like distilled water, so we're expecting na wala siyang laman na dissolved na solute. So, pag nag-strike ang light natin, so hindi siya nag-deflect ang light, so hindi siya nag-perform ng angle natin. On the other hand, pag madami kang dissolved na solute, pag nag-strike ang light, so, ganyan, di-deflect ang ating angle ng ating light here na nakukuha natin, ang angle niya, that will be corresponding here na tataas ang specific gravity reading natin. Another thing about your urinometer, this one is being calibrated at the temperature between 15 degrees Celsius to 38 degrees Celsius here. So therefore, medyo wide ang calibration nito ng temperature and therefore you don't need to correct for the temperature. Unlike in your refractometer, so correct natin ang temperature natin. But then you still need to correct for the glucose and the protein. Ganun pa din, in every gram per dl of your glucose, then you need to minus 0.004 the specific gravity reading. For the protein, every gram per dl of your protein, you need to minus 0.003 pa din. Okay, another instrument here for measurement of your specific gravity, we have your harmonic oscillation densitometer. So this one, try to measure the specific gravity in terms of the density expressed in terms of the sound frequency of sound waves. So the instrument itself is a U shape where you could put on your urine on that. One end of that contains an electromagnetic coil, and the other end would have your motion detector that would detect here the sound frequency. So it's based on principle here that you try to apply an electrical current para magdumaan ang ating sound frequency sa solution natin or your urine sample natin. So pagdaan ni sound frequency, the amount of the sound frequency na ibabalik niya will be dependent on how much of the solute dissolved in your urine. Like for example, sobrang lakas ng sound frequency, pag madami kang dissolved na solute dun sa urine natin, okay, it will strike, di ba? Sobrang lakas ng sound frequency, okay, pag bumangga doon sa ating mga dissolved solute, sobrang dami nila, ang maiiwang sound frequency ay konti na lang. That would signify na madami kang dissolved substance, and that would be expressing here as high specific gravity. Okay, so that's your harmonic oscillation densitometry. We have here the clinical correlations. So again, your ultrafiltrate of your urine would have a specific gravity reading of 1.010. More than 1.010 specific gravity reading, that's your hyperstenoria. Less than that, we consider it one your hypostenoria. Random urine would have a specific gravity reading between 1.003 to 1.035. Okay, urine sample having a specific gravity of less than 1.003 may not consider as urine. Sobrang labnaw niya, sobrang gaan niya. On the other hand, abnormal then if you encounter here a specific gravity reading of more than 1.035. More than 1.035 specific gravity reading may be related to the presence of your high molecular weight substances. Like for example, we have your radiographic contrast media when the patient's undergoing here procedure like electrocardiogram, something like that, where they give a contrast media to the patient. So the presence of this contrast media would increase the specific gravity reading here more than that abnormally high. Another one, high specific gravity reading here more than 1.035 may be because of the presence of your volume expander or your dextran. Okay, very high na specific gravity reading would eventually could not be measured anymore here by our instrument. So the best one, since kasi pag meron ito, so it would have your false increase in your specific gravity reading. If you try to read that one using your urinometer, refractometer, or your harmonic oscillation densitometer. So, ang gamitin mo para hindi maapektuhan ang specific gravity reading related to your dissolved substances, not because related to this one. Okay, so you could measure that one by the use of your recommended dito, gagamit ka nila ng reagent strip natin. The reagent strip here testified for the specific gravity reading is not affected by the presence of your high molecular weight substances. Therefore, it will give you an exact reading of your specific gravity here, regardless kahit may nakadissolve naman ito, because these are not really representing here the amount or the concentrating ability of our kidney or its ability to reabsorb substances. Okay, another one. So you could also have another option here. So abnormally high na specific gravity reading here could, the other option here is to dilute your specimen or dilute your urine. So like for example, if you have here, if you wanted to dilute your specimen in 1:2 na dilution, paano ginagawang 1:2 na dilution? 1 part na urine and 1 part na distilled water. Hindi siya 1 part na urine and 2 parts na distilled water. But rather, it's 1 part na urine and 1 part na distilled water that gives you a 1:2 na dilution. So like for example, after dilution, you try to measure the specific gravity of the urine and you got here 1.025 na specific gravity reading. Okay, so the actual specific gravity here should eventually be obtained here by multiplying the 3 decimal here of your reading by your dilution factor. Our dilution factor is 2, that gives you 1 is to 1.050. That's the actual na specific gravity reading after you have diluted your, the actual specific gravity reading here. Okay, after you have diluted your specimen. After dilution kasi, ito na siya, di ba? Since dinilute mo siya into half, so the actual na is 1.050 or 1:2 na dilution, I mean. Okay, the last one, we have here the odor of the urine. Although routinely, we are not reporting the odor of the urine in the result form for your urinalysis. But taking note of the odor of the urine provides you with some metabolic disorders or even mga inborn error of metabolism here, mga inborn error or inborn na mga disorders sa baby. As with the odor, the normal odor is aromatic. It become ammoniacal again because of bacterial decomposition, because the breakdown of your bacteria by the urea to your carbon dioxide and ammonia. Mousy odor related to your phenylketonuria, rancid to your tyrosiluria, sweaty feet with your isovaleric acidemia, cabbage with your methionine malabsorption, maple syrup urine disease related to your maple syrup odor. And we have your fruity odor related to your diabetes. Okay, so that's it for your that's it for your macroscopic or physical examination.